The broadcast is now starting. All attendees are in listen-only mode.
Welcome to tonight's vBrownBag. My name is Frank, and with me I have Lior Kamrat today. Just a bit of housekeeping before we kick things off. Today's session is going to be about infrastructure as code. Lior will give us a short introduction about what that actually means if you haven't heard about it. If you have any questions, I believe Lior is very happy to take them on as we go. You don't need to wait until the end of the webcast. Am I right, Lior?
Yeah, sure. I'll do my best to try to coordinate between the question and the presentation.
Yeah, perfect. So if you have a question, simply raise your hand or use the chat functionality or the question functionality. I'll also be monitoring the Twitter hashtag, hashtag vBrownBag for any incoming questions. And we basically run these shows on a weekly basis, also in US and Latin American hours. And with that, I'd say over to you, Lior.
Yeah, thanks, Frank. Thanks for having me, BrownBag crew. It's been long waited for me to do a BrownBag session. Took some time, but we finally got there. So yeah. So hi everyone. Frank, do you see my screen? We good?
Yes, I do.
All right. So hi everyone. My name is Lior Kamrat, and today's session is about infrastructure as code, getting started, concept and tools. Something that it's been dear to my heart. I've been doing this kind of stuff for almost the past 2 years. For those of you who are not familiar with me, my name is Lior Kamrat, or also Leo or LK. I found those names are much easy to pronounce for Americans, so you can call me that as well. I'm an Azure Cloud Solution Architect for Microsoft for the past almost 2 years. I used to work for VMware with the professional services from VMware. I'm a double VCDX number 230 board for CMA and DCV. In the past year, I also act as a panelist for Virtual Design Master. If you're not familiar with Virtual Design Master, please go ahead and look for it. It's an awesome IT reality show that we are doing. We just finished season 5, so look for season 6. It's awesome. I'm also a Pop Funko collector, so you can see 2 of my my Pops, Brain and Pinky, and I blog at imworldvirtual.com and tweet at Lior Kamrat. So before I get started with infrastructure as code, a quick disclaimer. So forgive me about all this buzzword bingo that I'm about to use, but it will be technical with demos. I do promise that. Also, it's not going to be a Terraform session, although I am mentioning Terraform quite a few. It's not a Terraform session, but we have one coming next month that I'm going to talk about that close to the end of the presentation. So wait for details. All right, so I prepared a packed menu for today. So let's go over that real quickly. So I'm going to talk about the old days and the new days, what I like to call the iron and the cloud age of IT. I'm going to try to define what is infrastructure as code or from code, tooling categories. The first demo will be around Packer from HashiCorp and imaging, mutable and immutable infrastructure, imperative code versus declarative code. Another demo around Terraform and how to provision stuff specifically in Azure, and I'm going to talk about that. A word about desired state and what it means. Infrastructure as code stack deployment approach. What are the players in that space? I'm going to talk a bit about Terraform and do the final demo around security enforcement with Terraform, and I'm going to summarize with good versus evil. So, for those of you who are interested in history, you know that there was an age in history called the Iron or the Bronze Age, somewhere around 1200 before century and 600, depending on the region you were at. The dominant tool-making material was iron. It was used for making weapons, jewelries, cookware, etc. The reason I'm mentioning the Iron Age is because I believe that there was an Iron Age for IT. In the Iron Age of IT, systems were directly bound to physical hardware. Provisioning and maintaining infrastructure, everything was done manually. That forced the team to spend so much time on tedious operations like pointing and clicking and typing, those kind of stuff, only to keep the lights on. And because everything was involved with so much work, change management processes, they forced us to carefully plan for DR, for big bang project, design operation, those kind of stuff. And as a result, everything was very expensive. Like, you couldn't get stuff wrong, so you had to go through long processes of design and review those designs. And now we have the cloud age of IT, also known as the unicorn era, where all the cool kids are doing DevOps and you no longer script, you just code. But what it means, apps have been decoupled from the physical hardware, and routine provisioning and maintenance can be delegated to software system, right? So that means that the IT staff, the teams that used to do those tedious operations that I mentioned, are subject to change. Excuse me. Changes can be made in minutes, if not in seconds, and change management processes can exploit that speed. They can provide better reliability along with faster release cycles. And later on in this presentation, I'm gonna demo what it means. And with that, enter infrastructure as code, which is the topic that we're gonna cover today and all the things around that. So let's try to define what is infrastructure as code, or also referred to from code. The reason that you have infrastructure as code and from code, if you think about that, you are describing infrastructure in code, but you're also deploying infrastructure from that code. So that is the reason why you have both as and from. But let's try to define it. So infrastructure as code, or IAC, is an approach to infrastructure automation, and it's based on practices from the software development world. So for those of you who are familiar with those worlds and familiar with the lingo, that should be easy for you to grasp. It emphasizes consistency, repeatability, routines for doing provisioning and change management. This is another aspect of infrastructure as code. The consistency part is very important, and I'm going to elaborate on that later on. And also, everything is made by definitions. All the changes that you are doing, you need to define that first and then roll it out to an unintended processes that include validation. If you take that bullet point and think about that, that pretty much saying that you are taking your infrastructure as code concepts and infrastructure code to provision your infrastructure. You're taking this and make it part of your continuous integration and delivery process. So when you're talking about infrastructure as code, you have four major categories for how to enable infrastructure as code. The first category will be ad hoc scripts. The second will be configuration management tools, server templating tools, and server provisioning. And it's important to do this kind of differentiation. And let's go over those categories. So the first category is the most straightforward one. The great thing about ad hoc script is that you can use your popular general purpose programming languages and can write the code however you want. The problem with ad hoc scripts is pretty much the same. The fact that you have this choice can cause problems sometimes. But if you think about ad hoc scripts, what is it that you do? You are taking a manual work and breaking it down into steps, choose your favorite scripting language, define and write each of those steps in code, and execute the script. And as you can see on the right, you have like a simple example for a simple bash script that do apt-get, update, and install some packages, but that's it. That is your script. So after if you want to move on up the stack, if you want to do something that is a bit more advanced, you should think about other tools. And this is where configuration management tools are come into place. So if you heard about the tools like Chef, Puppet, Ansible, SaltStack, and others, all are configuration management tools. They are designed to install and manage software on existing servers. There are some things that you need to take under consideration when you are moving to configuration management tools. The first thing will be coding convention. With configuration management tools, you have consistency and predictable structure, file layout, you have parameters, secret management, etc. On the right, you can see an example for a Puppet playbook that will deploy, that will take a file and copy it into a server. Idempotent code. Basically, this is a big topic, but basically what it means that you need to, if you need to constantly executing the same code repeatedly while producing the same result. If you can summarize that in one sentence, that will be it. So the reason I choose to show you that example is if you will look at the code, you will see that what I'm doing is that I'm making sure if the file exists or not in the server that I want to deploy that file. If the file is there and I'm ensuring it present, so I'm saying replace no. This is the flag in Puppet saying that please don't do that. So that means I'm taking under consideration the fact that I already have the file. That means idempotent code. That means that nothing will happen if it doesn't need to happen. And that also relates to state management that I'm going to talk about with our Terraform examples later on. The third thing with configuration management tools is distribution. Unlike ad hoc scripts, they are designed to specifically managing large number of remote servers. It's not just servers, but servers is the best example. So try to execute a script on multiple servers and for you to have some sort of governance on top of it. That will be hard to achieve. With configuration management tools, you can do that while leveraging the idempotent code convention. You can leverage the conventions that you have in parameters and secret management, those kind of stuff that are hard to achieve with ad hoc scripts. So this is where configuration management tools are coming handy. Writing an ad hoc script that works once isn't too difficult. Writing an ad hoc script that works correctly, even if you run it over and over again, is a lot harder. And for those of you that are scripting, you know what I'm talking about. So the third category.
It gets a lot of fun when you have 5 different versions of your scripts on 15 different servers, right?
Oh yeah, for sure. For sure. So this is where things are getting interesting. And with configuration management tools, you can put things into order. That's the best thing about that. The third category will be how we are doing the templating. I'm sure you heard about at least 2 of those technologies like Docker, Packer, and Vagrant. And if you're not familiar with Packer coming from HashiCorp, I'm going to show a demo here in a second. But the idea behind server templating tools is to create an image of a server that captures a fully self-contained snapshot of the operating system, the software, the files, and all other relevant details, right? Since we are in a vBrownBag, most of the audience is VMware admins, people that are used to work with VMware technology. So snapshot and imaging and templating is something that they are very familiar with. But what happens if you need to go out of your comfort zone? What happens if you need to work with stuff that are not VMware related? It needs to be part of your pipeline, right? So on the right, you can see an example to a Packer JSON file. And don't worry, if you don't understand anything, I will show you in the demo what it is. But basically with Packer, which come from HashiCorp, like I mentioned, you can do server and container templating, right? You have a concept of builders, and builders means that you can, so builders basically expose APIs coming from all the big players. So for example, Microsoft with Azure, or AWS coming from Amazon, VMware, Docker, Google, GCP. So all those platforms are exposed for Packer via API, and what you can do is you can do the templating via the tool. The good thing about that is that the same imaging processes, the same templating process is the same for every kind of operating system or virtual machine or container. The process is the same, making things a lot easier for you to put inside your continuous integration process when you are doing your builds. If you are creating an image of a container and it's the same like you are doing for a virtual machine, that will make your life a lot easier, right? After you are capturing your template, you are moving on to the deployment step in your pipeline, right? This is where Terraform will come handy to deploy those images that you just created into the targets, all right? So for example, you captured an image with Docker, you wanna deploy, I don't know, a bunch of those in order to test your application. That's great. You can do that with Terraform, and with that, you have the entire pipeline, well, almost the entire pipeline, but those are very big chunks out of the pipeline already made. So that's good. Server templating is a key component to shift to immutable infrastructure, and I'm going to talk about immutable infrastructure. The fourth category will be servers or resources provisioning tools, right? So provisioning tools such as Terraform or Azure Resource Manager, templates, AWS CloudFormation, OpenStack Heat, every one of those tools is responsible for creating servers, right? So on the right, you can see an example to a Terraform plan, which also be our example in the demo later on. The thing with server provisioning tools is not just for provisioning, all right? You can use those tools not only to create the server, but also other resources, all right? So resources is part of the, let's call it the cloud terminology, and they can be databases, load balancers, firewall settings, storage, subnets, whatever it is that exposed via the API, considered to be a resource, right? So it's not just servers. And it's multi-platform. And what multi-platform means is that all the APIs that are exposed and developed for Terraform are in the website, all right? So you can see here, just a sec. You can see here in Terraform website, you can see all the providers. So providers is the way for Terraform to talk with the different APIs. So you can see the amount of providers you have to choose from, and every provider expose a different set of tools, sorry, a different set of APIs in order for you to deploy from, which is great. And there is so much more. I'm going to talk about Terraform later on during our demo. And also, like I mentioned, we have an entire session coming next month. So with that, let's start the first demo, and let's do an image capturing with Azure Virtual Machine, right? So I'm using Visual Studio Code, and I can't stress this enough. This is a great IDE environment. If you're not familiar with Visual Studio Code from Microsoft, it's an awesome IDE environment. I don't know what you are used to, but for me, this is probably the best way to script, to code. And the best thing about Visual Studio Code is the fact that it's extendable. So you can go and deploy your own plugins from the marketplace, right? So if I'll go here, you can see that you have bunch of plugins that you can choose from in order for you to work with your favorite favorite scripting languages, all right? So that's just an example. So in that case, in our specific demo, I'm using Packer in order to do a deployment. An image deployment, image templating. Sorry. So Packer is using JSON in order to describe how the template will look like. And as you can see here, the top part of that JSON file is variables, and those variables are hidden in that file where I have all my secrets and user principal names for Azure. This is the way I'm connecting to Azure and doing stuff on top of the platform, on top of the API, right? So I'm not going to show that, but you can see here that in the builders part, right, I have the name of the resource group that I'm going to work against in Azure. I have the name of the image, which is my Packer image. I have the operating system, the version, and I can also use provisioners with Packer. So provisioners is a way to do other stuff on the operating system that you are capturing before it gets captured. So in that example, right, I'm doing some very boring stuff like apt-get, upgrade, and install nginx, but it's just an example for you to see what you can do that's got nothing to do with the templating mechanism by itself. But what you can do is you can do stuff on the virtual machine that you want to capture as part of your build process, all right? And that way you won't have to do that over and over again. You will have some sort of common ground with your images, all right? So this is the JSON file that will describe my template, all right? So let's go to Azure. Let's go to Azure Portal, all right? And you can see here in Azure Portal, I'll go to my resource group, and you can see here that I have a Packer demo resource group, which is empty. By the end of this session, because the templating takes a bit of time, you will see here a new image. So let's see how that works. So I have a CMD window here, and I have all the files that I need in order for me to do Packer image. If I'll go and do Packer, you will see that there's not too much into it, all right? You have build, fix, inspect, push, validate version. You have a bunch of things that you can do with that. But what you're gonna do now is we're gonna run a build command in order for us to use the vars files that I have with all the secrets in order to create the new Ubuntu image in that case, all right? So I'm gonna go and do Packer build. I'm gonna point into my var file, which in this case is vars.json. And then I'm gonna target the new Ubuntu image JSON that we just saw in Visual Studio Code, right? Once I'll do that, you will see that Packer will start doing some stuff. When Packer is doing the imaging process, all right, it creates a temporary resource group on the side of the target resource group that you want to save your template to. So let's see how it looks. So you can already see that it started a deployment of the template in a resource group called Packer resources group, and then just a random GUID. Let's see how it looks in the Azure portal. If I'll go here to, just a sec. If I go here to my resource group, you can see a new resource group that has been created with some random name. And what you will see here, you will see that Packer deployed a new Azure virtual machine, and he started to do things on that virtual machine. So he deployed the virtual machines, deployed the image which we choose, which is Ubuntu in that case. And then don't forget, I'm using provisioners. So I'm also installing nginx and doing the apt-get update, all those stuff. Once that is done, you will see a new image created here in the Packer demo resource group, which currently empty, all right? So we're gonna circle back into that later on because the process takes a bit of time, all right? But you can see here that it's already been created. Great.
From a Packer perspective, I mean, you're using the example of Microsoft Azure here.
Yeah.
Does that work against other cloud providers as well? I mean, AWS is pretty pretty well known.
So you can see here that in the Packer website, you can see all the builders that are currently available. So you can see Amazon EC2, you can see Azure, you can see ECS, you can see Google, VMware is there as well. So let's jump into that for a second. So you can see you can work with VMX and ISOFile to use that in order to do the imaging, right? So yeah, you have, well, all the big players are here in terms of working with Packer, and it's very easy tool to use. So I encourage you guys to go look into that and start doing some stuff.
From a licensing perspective, is there a free demo version available, or is it complete open source and free?
It's complete open source and it's free. Packer is completely free. Terraform is free as well. There is an enterprise version, but I'm gonna work with the free version, which with that, you can do pretty much everything.
So very home lab friendly indeed.
Oh, for sure, but not just. All right. So with that, let's kick it into gear and talk about mutable versus immutable or and immutable infrastructure. This is a big topic in the world of infrastructure as code. Mutable infrastructure, with mutable infrastructure, you will continually continually update, patch, and tune to meet the ongoing needs of your application. All right. For example, if you tell Chef to install a new version of OpenSSL, it will run the software update on your existing server, and changes will happen in place. Right. CM tools such as Chef, Puppet, Ansible, SaltStack, they typically default to a mutable infrastructure paradigm, right? It's not just, but this is most cases you will see those tools used in that fashion, right? Over time, when you are applying your changes, so let's assume you did for example, the OpenSSL patching, and you now have version 1.1 of that process or service. Over time, as you apply more and more updates, right, each server can get into a situation when it has its own unique history and changes, right? As a result of that, right, each service becomes slightly different than all the others. That can lead into a situation when you have configuration drift. It can cause bugs, and also it can cause inconsistency within your pipeline, meaning that you can get into a situation when your test servers or your test containers or whatever it is that you are doing are not the same as your staging or as your QA or, God forbid, in your production environment, which can cause some problem. You can see the potential problems coming with that kind of approach, right? It's not just that approach it's not that it's bad, it's just a matter of knowing your use cases. With immutable infrastructure, you're basically deploying a new infrastructure, all right? You're using, for example, Terraform to deploy machine images created by Docker or Packer, like we just did, right? And the changes that are made is pretty much deploying a complete new application version, right? Using the term immutable to describe this pattern can be a bit misleading, because immutable means that a thing can be changed. So a truly immutable server will be useless. As soon as a server boots, its runtime state changes, right? Processes run, entries are written to log file, application date is added, updated, and removed, right? It's more useful to think of the term immutable as applying the server's configuration rather than the server as a whole. This creates a clear line between configuration and data. It forces teams to explicitly define which element of the server they will manage as configuration and which element will be treated as data. I think a good example for immutable infrastructure will be these days mobile phones that you have. So today mobile phones, you have the batteries that cannot be replaced, right? So instead, what do? Instead of upgrading, you are going and purchasing a new device, and then you are throwing away your old device. This is immutable mobile phone, right? So you can think about that as an example. So once you deploy the new application, once you deploy the new infrastructure, you have a new version of the application, and then you can go ahead and destroy the old version, all right? You don't have to do that if you are working in a blue-green fashion. That means that you have two infrastructures serving the same application, for example, but with different version, all right? You can go ahead and leave those up and running, and then using some load balancing or networking manipulations in order for you to test the new version without destroying the old one, all right? This is also referred to as blue-green deployment or blue-green upgrades, all right? It reduces the likelihood of configuration drift and bugs. It makes it easier to know exactly what software is running within the server, all right? If you are doing things in an immutable fashion, that means that you need to be less considerate about the history of your application. You're just deploying a new version and everything is potentially aligned, right? It also means that automated testing are also more effective, right? Immutable images that passes your test in test environment are likely to behave the same in your production, for example, right? So think about the pipeline that I mentioned with mutable infrastructure. With a configuration drift, you have the potential of basically making your pipeline inconsistent, right? With immutable infrastructure, the potential for consistency is much bigger. And like I mentioned, this can also be referred to as blue-green methodology. If you are interested in reading blue-green, I encourage you to go and read Kubernetes documentations around blue-green. They have some good examples and great use cases for those kind of scenarios, but it falls into the paradigm of immutable infrastructure. So I'll try to summarize that topic with mutable and immutable. If you ever heard about the debate around the pets versus cattle, this is where it falls. This is where this debate gets relevant, because with pets, that means that you are hand feeding your pet, and this is the example I gave around the service upgrade that you are doing with Chef to the OpenSSL that you can see on the left right here, right? But when you are looking at your infrastructure and address it as cattle, that means that you are taking your entire infrastructure and just clone it or deploying it somewhere else without need to worry about a specific object or a specific service or specific server within your infrastructure, all right? I want to say that one approach is not necessarily better than the other. It really depends on the use case, all right? The fact that you are looking into immutable doesn't mean that you won't use mutable methodologies, but it really depends on the use case, all right? With the mutable approach, you do need to take into consideration that the team needs to be aware of the infrastructure history, so to speak, all right? It needs to know the relevant pieces within the infrastructure, and sometimes it also needs to know the order that they need to be installed, which makes things sometimes a bit harder to manage, right? Generally speaking, the immutable approach is better for stateless applications, all right? So if your applications can work in a stateless mode without being dependent on a local data and can connect to something that is more persistent later on, that's great. You can go and start looking into immutable, right? And it also drives no deviation and no changes. It is what it is. Immutable infrastructure means that you are basically deploying everything from scratch based on the build. So if you are doing a new build within your pipeline, that means that potentially you will deploy an entire stack of infrastructure just for that build, right? With all the benefits that comes with that. So the second topic, or the third topic for that matter, is imperative code versus declarative code, which is also a big topic in the world of software engineering, and by that, infrastructure as code. But I'll try to explain it in a way that will make sense to you guys, all right? So imperative, which also known as procedural, is the how. It's a historical approach which uses the I don't trust you, give me the actions parameters in explicit steps, right? You are defining specific commands that needs to be executed, right? So let's do an example here, because I found that the easiest way to explain what imperative code means. So if you're not watching Rick and Morty, which is the best show on television these days, I took the example from Rick and Morty. Let's say I want to explain someone how to get from his house to mine, right? So the first step, I will tell him, leave your house. Second, get into the car. Then I will tell him, listen, drive straight on Morty Boulevard for 3 kilometers and turn right on Rick Street and drive for 5 blocks. Then you will get to my place, which is obviously this one. My house will be number 9 and will be on the right. So you can see here that I'm actually describing steps and commands to the user in order for him to get from point A to point B, right? So this is the way to make out an example of an imperative code, right? Procedural code does not fully capture the state of the infrastructure, right? If we are doing the comparison to code, all right, procedural code does not fully capture the state of the infrastructure, all right? Reading through, for example, Ansible templates is not enough to know what was deployed, right? You also have to know the order which those templates were applied. Had you applied them in different order, you might have ended up with different infrastructure, all right? And you have to know the full history, right? We talked about it with mutable infrastructure, right? This is also, everything is connected with one another with infrastructure as code, which is something that you need to be aware of, right? There are some limitations coming with procedural code methodologies, all right? The reusability of the code is limited. Because you have to manually take into account the current state of the infrastructure, right? In that example, I needed to know that the user left the house, right? I needed to know that he got into the car and so on, right? So as a result, procedural code tend to grow large and complicated over time. So declarative or functional, right? Declarative or functional is basically the what. This is what I need. I can't be bothered telling you how to get there, right? This is the approach. The how is handled by some sort of engine that is not the administrator, like with imperative code, right? The sysadmin described a desire and state, and the tool attempts to reach it, right? So how the example that I gave you with imperative code will look with declarative code? Pretty simple. My address is 9 Rick Street, Tel Aviv, Israel, right? And that's it, right? But it's not everything is happening with, like magic. You need some sort of engine behind the declarative methodology. So obviously, right, you have some steps along the way, but with declarative code, right, your tooling knows the state of the infrastructure, right? Regardless of how you got to your house, what really matters is the car you drive in, right? Am I going to drive an imperative stick shift car or declarative automatic car, right? Before we dive into code, it's important to realize that many declarative approaches have some sort of imperative abstraction layer, right? Like you have with your automatic car, right? It has some sort of abstraction layer over the shifting gears, right? This is important to understand when you are working in a declarative fashion, right? Imperative is not go away, it's just a matter of masking it somewhere, right? Before diving into more demos, I want to talk for a second about the desired state and what it means, because I mentioned that several times, but let's take this into an example. So on the left, you have an Ansible playbook, right? On the right, you have a Terraform plan. Firsthand, they look the same. You are creating a VM, you are telling the code or you're telling the tool how many of those virtual machines or servers you want to deploy. In that case, we have 5. And where do you want to deploy them and what will be the type of the virtual machine? That's great. But what happened if something needs to be changed? So with Ansible, look how I changed, or notice how I changed the count to 10, right? What you would expect is you will have 10 servers at the end, as the end result. But with Ansible, that will not be the case unless you are putting some sort of logic, which I'm not gonna go into with wrappers and those kind of stuff. But generally speaking, and out of the box, you will get 15 servers, which is not the state that you wanted to go with your deployment, right? With Terraform declarative approach, things are a bit different, right? I'm changing the number of servers that I want to deploy to 10, and eventually I will get 10 servers, right? With Terraform declarative approach, the code always represents the latest state of your infrastructure. You can tell what's currently deployed and how it's configured without having to worry about history or timing, those kind of stuff, right? It also makes it easy to create reusable code, as you don't have to manually account for the current state of your infrastructure. You just need to focus on describing the desired state of the infrastructure, right? So with that, let's go and do another demo. Before that, let's check our first demo and see the status. So you can see it's already done. You can see the image that we deployed, my Packer image. It's deployed in that resource group in a region West Europe for Azure, right? If I'll go to the portal here, you will see the image right here. So you can think about the potential here that I just captured an image, and I would have done the same. I would have used the same methodology regardless what kind of image I wanted to capture. All right. So it doesn't matter if it's a virtual machine coming from VMware, Azure, AWS. If it's a container, it doesn't really matter. The methodology and the code terminology will be the same. Right. So this is very important. Very important to understand. So with that, let's move on to our second demo, which is provisioning Azure Virtual Machine with Terraform. So I'm going to open a new Visual Studio Code window here. Here I have a resources.tf file. So TF files are Terraform files, and the resources file is the file that will describe the environment that you want to deploy. So if you remember at the beginning of the presentation, I told you that you don't have to deploy just servers, you can deploy resources, all right? So in that example, you can see that I'm not just deploying, for example, a virtual machine, and let's try to find that here in the code. So you can see here the part that I'm creating a virtual machine and describing how that virtual machine will look and what kind of type of virtual machine I'm going to use. But I'm also deploying with my code the disks for that virtual machine, the resource group in Azure, the virtual NICs. I'm also creating security groups that I'm going to use later on in the third and last demo, right? So you can see here that in that code, I'm using Terraform to describe the environment that I want to deploy, right? Specifically with Terraform, so you will work with providers, right? So here in that case, I'm using Azure Resource Manager Provider. So provider is the same as builders with Packer. Only provider is a set of API that's been exposed to Terraform via the different vendors and the different platforms in order for you to provision your infrastructure or your resources, all right? So let's jump into Terraform website here for a second, and you can see here under providers, again, you will see all the different APIs that you have for you to deploy from, right? If I'll go, for example, to Azure here, Microsoft Azure, you will see here that I have tons of resources that I can deploy using the same code with the same Terraform plan, right? So going back to the resources file here, I'm going to show you how to deploy that infrastructure and talk about Terraform here for a second. So with Visual Studio Code, that's another cool thing. You have an embedded terminal window, so I don't have to jump back and forth into my terminal window. So I can do everything from Visual Studio Code without jumping around, right? So here in that Terraform library that I have, you can see all the files that I will be using in order for me to deploy the infrastructure. And like I mentioned, this is not the Terraform brown bag. We will have more example and more logic behind the scenes in our session in 2 weeks' time. But what you should be aware of is all the files that I have, the variables files here that I have in order for me to describe what kind of variables I have in my deployment, right? I have the Terraform TF vars, right? This is the secret file that I have. This is where I will store all my passwords for Azure, and how do I get access to the API from Azure, right? So all those files are here in that specific folder, right? If I'll go and hit Terraform, you will see all the commands coming from Terraform. So you have tons of options with Terraform, tons of cool stuff that you can do with that, right? Probably one of the best things about Terraform is the Terraform plan, right? So Terraform plan gives you a way to, just a second. So Terraform plan will take all the files that you have in that directory, in your working directory, and it will describe to you what is about to happen. This is a very good option for you to work with because you don't have to do changes. You can see the changes that are about to happen or the new deployments that are about to happen before you're actually executing something, right? So you can see here with that plan, I'm going to deploy 8 new resources, right? So those resources are virtual machine, virtual network, network security groups, etc. All right. I have nothing to change because it's a new environment, and I have nothing to destroy at that moment. The command to execute the actual deployment will be terraform apply here, and because I have the terraform.tfvars file here in that folder, it will automatically take the secrets and will use them in order to get access to Azure, right? So I'm gonna hit terraform apply here, and you can see here you can see here that a new file started to get created, which is the TF state, right? So this is the file where Terraform will store the current state and the end state after the deployment will finish, all right? So you can see here the deployment started to happen. All the resources are starting to get deployed, right? If I'll go into Azure here, go here and to my resource group here for a second, and you can see here the Terraform demo resource group, which just got created by the Terraform plan. If I'll dive into that one, you will see that the resources that I described in my Terraform plan are starting to create, and soon everything will be up and running, all right? We're gonna use that demo in order to move on to the third demo in a few minutes, right? So in the meantime, I'm gonna give Terraform its time, and we'll let Terraform do its thing, all right? It will take no more than a few minutes. So when you are deploying infrastructure as code stack, you basically have 2 approaches to attack kind of deployment, all right? The first approach will be the pull master agent, and the second approach will be push masterless agentless, right? So the first approach, let's talk about the good things about that approach, right? But before that, let's describe what that means, all right? The server is being provisioned, called a node, runs an agent, which called the daemon, that asks the central authority, which is the master, if and when it has any updates that it should run. Once that is done, requires the daemon to be installed on all the machines, and the central authority to get deployed, all right? Once that's done and the node is asking the central authority for the changes, right? It will pull all the changes and start the deployment, right? So you have a central place where you can manage the status of your infrastructure. Some tools provide a web interface. So a good example would be Puppet Enterprise Console or Chef Management Console, and you get some sort of scalability, all right? Chef is a good example for that kind of deployment because it uses agents in order to deploy files and artifacts and binaries, whatever, all right? You can use Chef without the agents if you want to just deploy servers or virtual machines, but the reason I gave Chef as an example is because it requires by design to use agents in order to do changes on an existing infrastructure, right? The cons with that kind of approach, it requires a daemon to be installed on the machines and a central authority to get set up, right? That means you have extra infrastructure more maintenance and some security constraints that you need to go through. And generally speaking, it's a bit harder to manage. You have more moving parts. You need to make sure you have high availability for your master servers, etc. Right? So this is the pool and the master agent approach when you are deploying your infrastructure as code infrastructure, if you can say that. The second approach will be push, masterless, and agentless, right? A client connects to the nodes and send updates as they are needed, right? When change is made to the infrastructure, every one of those nodes is alerted, and then all the changes are running, right? So Terraform, for example, it uses API calls to the different platforms. So like we just did in the demo. So I used to work against Azure, and then I deploy virtual machine in Azure, right, via an API call, right? It's simple to manage and set up, but you don't have a central control plane. If that's a requirement coming from your organization, if that's something that you think you need. So there are some offering coming from HashiCorp, for example, like Atlas, right, which can get integrated into Terraform deployment. It's just an example, but generally speaking, those kind of infrastructure stacks for infrastructure as code do not have central control plane. If that's an issue for you, there are ways to go around that, but you should be aware of that. So we are almost at the end of that presentation, and I wanted to start summarizing with the major and cross-platform players, right? So the big five that I'm currently seeing in the wild are Puppet, Chef, Ansible, SaltStack, and Terraform. And you can see here in that table that there are some differentiation between the tools. Terraform is the only tool here for doing actual provisioning resources. It works in an immutable way, but the other tools are working just the same. It really depends on what you are trying to do, all right? The main thing will be how you are describing the deployment, all right? Would it be declarative? Will it be imperative, or both, right? You also have differences with the language that you are using in order to create the playbooks or the plans. It really depends on the terminology of the tool that you are choosing. But most of the tools have a very understandable language. YAML, Ruby, a bit less easy, at least for me. But with HashiCorp, for example, they have their own language, HCL, HashiCorp Configuration Language, which is pretty easy to understand. If you notice in the code, it's pretty easy to understand what is it that we're trying to do, right? You have more tools and platforms out there that you can use in order to do some infrastructure as code. Not all the tools are doing the same, but overall, they are part of the ecosystem of infrastructure as code, all right? So you have Docker that you can use with Docker files, for example, in order to do some sort of templating or imaging. And you can go and use Packer for just standard imaging, all right? Even Bash scripts are part of the infrastructure as code ecosystem. It really depends on the use cases and what is it that you're trying to achieve. So just a quick bullet points around Terraform versus all the rest. It's cloud agnostic. Well, kinda, because with Terraform you have multiple platforms, but every platform, so for example, Azure and AWS are exposing different APIs. That means that you need to be aware of those APIs, but the methodology that you are using in order to deploy those resources in those different platforms is the same, right? The Terraform plan, we saw that, and the power of the Terraform plan that you can use in order to see what is about to change before executing something. You have state management, so Terraform is saving the state of the infrastructure, and then every change that you are doing, taking the state under consideration. Terraform will do that for you, right? Modules in Terraforms are self-contained packages of Terraform configurations that are managed as a group. Modules are used to create reusable components in Terraform, as well as for basic code organization, right? And the HCL coming from HashiCorp that I just mentioned. Obviously, there is more into that, and that will probably be the last time that I mention. Oh no, we still have demo, but We do have a session as part of the API 0 to Hero series, myself and Byron. And if you're not familiar with Byron, he is also a great person to listen to when it comes to those kind of topics. So I highly recommend you register to vBrownBag and look for the session that is about to happen in 2 weeks. The entire series is great. I watched several of those brown bags. It's highly recommended, right? So just stay tuned for those brown bags. With that, we are in the final demo for our session. And what I'm going to do is I'm going to use the deployment that we just did with Terraform, and I'm going to do some modification. In that specific demo, I'm going to do some sort of security, although it will be very easy to understand and not a real life, well, I'm not sure if not real life threat, but it's very easy use case, but it's just an example of what is it that you can do with enforcement, right? So if I'll go back to Visual Studio Code here and look at the deployment that we did with Terraform, so you can see the deployment is finished. We now have 8 new resources. Nothing has changed, nothing got destroyed, but new 8 resources just got deployed. So if I go quickly to Azure here and to the Terraform demo resource group, so you can see I have all the virtual machine, I have the virtual machine and all the resources and the ecosystem for that virtual machine deployed, right? So with enforcement, if I'll go to the network security group, which in Azure, it's like access list basically, right? If I'll go and let's say someone got access to my API or my Azure portal, right? And he wants to do some sort of change. So for example, I'll take the allow SSH rule that I have here in this network security group, and I'm going to change the port 22 into any. So you can see the potential, the problematic potential here. So it will allow users or attackers to log into that virtual machine from any port, right? So that can be a problem. So let's do that change here. So I'm going to change 2020 here to star and save it right here. So it will take a few seconds here and you will see that that's already got changed. So you can see here that now allow SSH rule has changed from 22 port to any port, right? Now let's go to Terraform here and we'll run the Terraform plan, the same Terraform plan that we just used to deploy the infrastructure, and let's see what will be the result. And let me remind you here that in that Terraform plan, I also used that to deploy the rules that I just changed. So you can see here, this is the original state in the Terraform plan, right, for that specific rule, right? So Azure Network Security Group, I just deployed that with my infrastructure, and I allowed port 22 as the destination port for that network security group. But I just changed it in my Azure portal. So let's run Terraform plan again and see the result, right? So I'm not executing anything, I'm not changing anything right now because I want to leverage Terraform plan. And you can see here that Terraform, because it's aware of the current state of the infrastructure that we deployed, you can see that Terraform is recognizing the change that we just did, right? So it recognized the fact that instead of star, that should be 22 port, all right? So let's run the Terraform apply here again, and it will take a few seconds. Let's go and see what happens in Azure portal. So in Azure portal, if I'll go here to the, if I'll go here to my rule, you can see that the port has changed and now I'm enforcing that policy or that state, right? So if you think about the use case, you can just make the Terraform apply, listen to your infrastructure, and no matter what happens, it will always stay consistent because you are describing the end state for your infrastructure, right? Let's go back to infrastructure code here, and you can see that one thing has changed, which is the port from star to 22, right? So to summarize, infrastructure as code, let's talk about the good versus evil. What is good? You are supporting and enabling change within your organization with infrastructure as code. If you are embracing those methodologies and those concepts, all right, you're not an obstacle anymore. You're not a constraint. Changes our systems, our routine. There's no drama or stress for users or IT. Everything is happening all the time, which is a great thing. You are investing time in valuable things. You are investing time on things that actually make a difference, and you're not spending time on repetitive tasks and tedious operations. You can define, provision, and manage your resources as they needed. You're not dependent, you as a user, you're not dependent on IT staff. If you are part of an IT staff, again, you get some free time to do other things. You are easily and quickly recover from failures, and you're not running like a headless chicken. If you are aware of the old days when you have run books for DR scenarios, those days are about to over, because if you are embracing infrastructure as code methodologies, you can actually describe the state that you wanna be in a DR scenario. Obviously, I'm simplifying it, but again, it's all about the methodology and embracing new infrastructure as code concepts, right? Improvements are made constantly. You don't have to think about patching and risky big bang projects, right? This is very important. Everything is happening all the time. All the improvements are happening constantly. And solutions are implemented and tested on like just the same, right? You are deploying something and it's being tested right away. So the cycle of managing your infrastructure is more reliable, faster, all right? And you don't have to spend time on trying to document and spend some time on meetings for those kind of solutions and offerings that you wanna give for your users. So with that, thank you very much. Happy coding. This is a very cool topic. I encourage you to start digging into it, and I hope you enjoy it. Frank?
Yeah, thank you very much, Lior. From a getting started point of view, I mean, the configuration files that you showed were rather long. And even though I think once you start using it, you'll see the patterns in how to build them. Do you have any resources to point people towards getting some experience with the syntax?
Yeah, for sure. So first of all, you can go, and if you are interested in Terraform, for example, go and look in their documentation. That's one. Second, my GitHub is out for grabs, so you have some examples over there, and I'm going to upload the examples that I used in that session as well. Safari is a great resource for ebooks. And I saw that there are some great courses down at Pluralsight, so you should go and check that out. There are a bunch of books around that and some e-learning. So yeah, you just need to look for it. It's pretty easy to find.
Perfect. Cool. Thank you very much.
Yeah.
And yeah,
thank you.
Thank you very much for presenting. And I look forward to watching your recording on the US show in 2 weeks as well.
Yeah, should be awesome.
Yeah, perfect. Thank you very much. And yeah, I'll see you guys next week. Take care.